So this is like the third time that I'm trying to record this, and due to different problems and a few mistakes that I made, so I'm gonna chop this into actually 2 parts to make it more manageable. And I wanted to explore a little bit more what I did with the PNG parser last time. So I made a few changes over here, and we're gonna go through them. But first, this is the specification that I used. This is the spec, and actually this is an older one from 2003. And I should have taken notice of it because it's all over the place, right? So we got the column 2003 here. It says November 10, 2003. And if you go to w3.org/tr/png, right, you're gonna find this version, which is actually very, it's even newer than my video, right? I recorded, I think it was on January 4th, and well, we got a revision from this year, from a couple weeks back. And what these versions cover, what these newer versions cover, actually it's the same. The CSS is much nicer, and they go into some details about PNG for animation and frame-based animation. But if you go to the part of the data stream structure, which is what we worked on the previous video, it's all about the same, right? And like I said, it looks a lot nicer. This would have prevented me from doing that silly mistake where I copied wrong the hex values, because I could have just copied this. Let me get, oh, I have it over here. You can do this. No, bytes from hex here, right? You can do this. And I could have done exactly that. And that would have worked a lot better than having to figure out what I copied wrong and all that. The graphics are a bit nicer. The figures are nicer, better looking. But all in all, it's just the same as before. Okay. So having said that, you may remember that do I want to import it? Let me check. Yes, it's saved, so I can import it. You may remember that I said, this is a big spoiler. You may remember this, me doing this, timing the parse function, and then saying, oh, right, it takes 541, and if we divide this, we know that it's about wow, what am I doing here that's so fast? Is this the improved version? Yes, it is. Okay, so this is what I wanted to work out. No, this is wrong. Oh, no. Little mistake there. I had an extra 0. You may remember this, right? It's reading, parsing at about 250 megabytes per second. And I said that that was good, but there were some ways in which we could improve upon that. And one tool that we're going to use today to analyze that is the line profiler. If you don't have it installed, you just have to run pip install line profiler, just like that. And I already have it installed. IPython is complaining about me doing a few things that maybe I shouldn't. And line profiler is really interesting. Python comes pre-installed with the cprofile module. It's part of the standard library. And cprofile lets you analyze how much time any function takes. Every function that is called when you run under cprofile, a timer is taken before the function call and right after that function returns for every function that is run. So we get a macro view of our code and which functions are taking a lot of time or maybe a little time. Line profiler, as the name implies, gives us the ability to see how much time any line of code is taken. And to do that, we have to work out either the profile decorator in our code. That's not something that I'm going to do today. I'm going to work directly from within the console. Okay, so in IPython, I'm going to load the extension for the line profiler. And having done that, I can analyze how much time any function takes. So I could run line profiler like this with the lprun magic command. And sorry about that, I didn't copy things. PNG, like that. So the first time I run this, nothing's going on. Why is that? Because I have to tell it what function I wanna profile. What are the function or functions that I'm interested in? So let me make this a little bigger. I could say, okay, I want you to take a deep look into parse PNG. And you can see a lot of things going on here. First of all, it's telling us how much every timer unit takes, right? So in this particular case, it's telling me that the timer unit is 1/10 of a microsecond. And the total time for this function was 6.7 milliseconds. You can see that it's taking, sorry, not lprun, time it. It's taking a little bit longer than just the standard code, right? Like any profiler, line profiler introduces a bit of overhead. But that's okay, because it'll help us see what's going on in our code. And we have a few columns here. The line number, this one corresponds with the code here, right? So you can see line 49, 64, 64, everything matches. And then we have the hits column that tells us how many times every line was run, the time that tells us how much time in total it took, and the per hit, which is the time column divided by the hits column. And then finally we have the percent of time and the line contents themselves. So we can see that 99% of our time is being spent instantiating our chunks, right? Creating our chunks from the file data itself. So we could run it again and say, okay, let's dig a little deeper and see what's going on. For chunk, for chunk, we can take a look at the dunder init function. And what we're going to find here is that copying things around as we receive them, it's not really something difficult, right? It takes very little percent of time. But the main culprit here is the parse function, which is taken 96% of the time. So let's analyze chunk.parse and see what's going on there. And we can see that the big bad, we could say, it is the CRC32 calculation, right? So I've made a few changes to have the flag CRC check passed as part of parse PNG as a keyword only argument. And with that, we can control what's going on. So let's go with time it so that we can run it pretty fast and without too much code on the screen. So according to our timings with the line profiler, 99% of the time is being spent creating chunks, and digging a bit deeper, we know that 96% of that is inside chunk.parse, and line profiler is telling us that about 66% of the time is spent on the CRC calculation. So we could say, okay, if we do flag CRC check equals false, this should run a lot faster. And if you remember from the previous video, we know that it actually doesn't. Okay, so we're running about 20%, between 15 and 20% faster. That varies from run to run because there are things running in the background of my computer right now. But this looks really strange because we know that we had 99 and 96% of the time, and 63, let's say 65 to round it up, about 60% of the time should be spent on this CRC calculation, right? That's not quite right, actually. So let me copy things around and we'll analyze. So I'm gonna copy the imports. Oh, like that. I'm gonna copy the regex and the ctype validation function. That's okay. I'm gonna copy chunk over here, and I'm gonna copy finally parse PNG. No, why twice? My bad. Okay, so we have everything in place right now, and I wanted to have those things in place because, let me run this just so that we can check we're really doing things about the same. And with everything in place, I can do a few tests and we can verify our assumptions. And there's actually a big assumption, same as before. So I said that when we parse things, 99% of the time was being spent on this line specifically, but there's more than just instantiating the function going on here, instantiating the chunk. If we do this, like autocomplete wanted, exactly. This is from my previous tests. If we do this and we run the line profiler again, but this time on this version of the function, parse PNG like that. Oh, and let's make it bigger. We can see what's really going on here. So before that, we had that 99% of the time was being spent on chunk instantiation, but actually 70% of the time was being spent copying things around, right? When I do data and open brackets and slice the data buffer, the data bytes object, I'm actually creating a copy. And that's really bad. You can see there that it's taking 70% of the time, but it's actually taking even more of that. Because if I work over here, chunk.parse, like that, we can see that there are even more copies here. This is a copy, right? I'm copying things from this part of the data buffer that I received from another copy. And anywhere else, yes, this is a very small copy, not really important. And this is also a copy. So even these little things add up. Yet another copy, yet another copy. So these are really little things, but the big bads are this line right here and also this other line right here. Okay, and I do that again yet another time. So if we were able to reduce these things, right, we would minimize what's going on here. Okay, and to give you an idea of how much I'm doing over and over and over, this is a file that's 1.3 megabytes, 1.36 megabytes, a little bit of that. And for every single one of these chunks, let me do chunks, no, this chunks, and let me see if I can get this. Okay, so how much are we copying around? Well, let's sum it up. So this is I have to take this minus chunk dot start for chunk in chunks. Is that correct? I'm copying from the start up until the end of the file for every single chunk. So 25 times. These are 25. I know from the hits, and we have to divide it. Okay, so to give you an idea, the file is 1.36 megabytes long, and I'm at least copying around 18 megabytes to parses. All right, and if I had a much bigger PNG file, this would be substantially more data being copied around. If it were 100 megabytes of file, for the first chunk I would copy 100 megabytes, for the second chunk I would copy about 100 megabytes, and so on and on and on and on. Okay, now we are reducing how much data we copy for every single chunk, but we're still copying a lot of data that we don't need. So let's change then how this how the class works, how the parse function, the parse method, sorry, works. And actually, to do that, we have to change first what we're going to give to a chunk when we create it. And actually, we don't have to change too much. We will not be copying, we will not be slicing our data, because we're actually giving it the start position. And this is something that I carried over from the JPEG parser. I mentioned that before. The JPEG parser works, but there are some things that it has to do a bit strangely because of how strange JPEG is as a file format. And one of the problems with JPEG is that the data segments, right, the equivalents to PNG IDAT chunks, in JPEG, they can be any length. So even though every segment in JPEG has a length, the data segment does not follow that length. So whenever you encounter a data segment on JPEG, you have to keep reading byte after byte until you find a valid segment, a new valid JPEG segment. And that basically makes you read byte by byte, 1 byte at a time. Actually, I do it with regular expressions, but the processor and the regex engine, they go and analyze every single byte until they find a valid JPEG segment. And that's why I cannot trust in the JPEG parser, I cannot trust the segment's length. And so I have to go into this version, this code that copies from there onwards, because it doesn't know where it will end. But on PNG, we have a very clean format that doesn't have that flaw. So it's much cleaner, and we can change the parsing such that we will receive all the files data. And let me show you another thing that we're going to use. We're using struct.unpack, right? And if I have struct.unpack and I have to read value, if I have more than that, unpack is going to tell me, no, I need to have exactly this many bytes, what was defined by the format string. And actually there's a great tool in unpack, which is in the struct model, which is unpack from. And unpack from takes looks very, very similar, its signature, to unpack, but it takes the format string and the buffer, and it's going to unpack from that buffer whatever it finds. And the buffer doesn't have to be the exact length as unpack requires. That's one of the first great things. And the other great thing is that it can take an offset. So if I'm telling it the offset is 4, you can see that it's actually unpacking the 4 ones that I have right here. The only thing that I have to take care is that if I'm going to use unpack from and pass it an offset, it has to have enough bytes from that offset onwards, right? So that it will work as expected. And you can see that both unpack and unpack from gives us the same results. So what we're going to do here is change the parse function so that we're actually going to use unpack from right here. And what I'm going to do is I'm going to get the length right at the start, and I'm going to do, okay, so raw bytes is going to be data is going to be what we received from the parse PNG function, which is all the files data. And we know exactly that we have to start at self.start, and we have to go up to self.start plus self.length plus 12. And that way we're covering the length, the chunk type, all the chunks data, and the chunk CRC. And from this point onwards, I don't have to change absolutely any other thing from the function. Okay, actually I will change just this. My bad, sorry for that small lie. And having done that, we are good to go. So Let's see if it's still working. Great. Let's see again how much it took the original version, right? And how much this other version is taking. I cannot compare them with double equals because I did not implement the dunder EQ method. So that's still something that I'm owing to you. And this is really good because you can see the values are the same. Let me, yes, they are the same. So the parsing is working the same as before, but it's 2.7 times faster, just because I minimized the copies. Okay, so if I were to do a run just like before, let me, yes, we can see now that effectively 97% of the time is being spent on chunk creation. We're not copying things around, right? This line's commented, so that's why it doesn't have any information on the columns. And if we were to check what chunk.parse is doing, we're going to find now about the same as before. And here's the big data copy, at least the one that used to be big before. And now we're just copying around the, yeah, this is from the old one, right? So before we were copying around like 18 megabytes. And let's work out what we're copying around this time. So we're copying c.length for c in parse PNG data. So I'm parsing again. It's not really necessary, but what we're copying around this time, oh, I did not divide by like this. So we're copying around about the file's length. So that's 18 times or about 18 times less. Let's do it like this. We don't really need that much precision. 13 times less memory being copied over and over and over. That's really good. And even though memory is fast, if we don't really need it, there's no point in copying things around. And just like I said before, we find that this is 2.7, almost 3 times faster for the same result. So that's a big thing. And if I were to run the LP run once again, we can see that things are about the same as before. And our two big bets now are the copy here on line 29, right? And the CRC calculation once again. So let's see if this time around, if we were to turn off CRC, if we really gain about twice a 2x speed up or more, because it's telling us that it takes 60% of the time, or 52%, 56, sorry. And we can see that effectively by turning off CRC32 calculations, we're going 57% faster, right? So we chopped off a big part of the processing. And if I were to not time it, LP run, let me LP run, just like before, and here flags it false. And now we can see that effectively the biggest thing that's taking time is once again copying things around. And the question now is there anything we can do to make this better? Ideally, we would want to have something in place that allows us to not copy things around or copy them lazily. And there's actually something that can do exactly that. And we don't have to code any weird thing. And that's what we're going to work on the next video. So I think this is a great place to leave things as of now. And on the next installment, we're going to explore how to do this lazy copy, not copy actually. And it's going to bring us a few problems. I'm going to show you those problems and what we can do to solve that. But what we're going to gain is really massive with respect to what we have implemented here, because we can actually get to a point where no things are being copied around. And that's really interesting from a performance point of view. And we're also going to talk a few things about what does it really mean and if it makes sense to go really crazy with this sort of thing. But all that in the next installment. This is all for today, and I hope you enjoyed it.